This time let's try the elimination method. So I'm going to put parentheses around this top equation. I'm going to double the size of all of these values above. And the 2, it will distribute into each of these terms. So I'm going to rewrite the new equation below. So I have 4x plus 2 times 3 is 6. So I have 6y is equal to 12. I'm just going to make a little divider here. And I'm going to rewrite this equation below as well. I have 4x plus 6y is equal to 12. Take note here, look, both equations are identical to one another. So the cool thing here, if you were to actually graph this information or plot it on a graph, both lines would lie directly on top of one another. So for every xy value you have in this top equation, you'd have the same xy values in this bottom equation. Okay, so now I think you can probably see whatever values you plug in for x and y in this top equation, if you did the same to the equation below, you'd always come out with the same answer in the long run. The two equations are set equal to each other. They're identical to one another. But let's go through with the elimination method and see what happens. I'm going to make the variables additive inverses. Okay, so in order to do this, I'm just going to cut around this equation and then I'm going to get rid of it and rewrite it. But I'm going to rewrite it using the additive inverse. So I have negative 4x minus 6y is equal to negative 12. So now these variables, if I were looking at x, they're additive inverses. It just happens that the y variables are additive inverses. So let's see what happens here. Well, these cancel out, and these cancel out. I'm going to choose a new color. I'm left with 0 is equal to 0. This is a true statement, and it tells us that these equations have an infinite amount of solutions. So I'm going to write infinite. You could write infinite number or infinitely many solutions. And I'm going to box this information up.